In this video, we're going to discuss some more examples of the addition rule. Right, so below are the results of a study of 300 randomly selected hospital patients. Okay, the first question is heart failure and cancer, are they just joint events? Is heart failure and cancer, are they just joint? Well, remember, if they're just joint, then they can't happen at the same time, right? So the answer to this would be no, because look, we have 30 patients who have both heart disease, heart failure, and cancer, right? So there's 30 patients that say yes to heart failure, yes to cancer. So no, heart failure and cancer are not just joint. Okay, let's go on to the next question. Find the probability that a randomly selected patient has heart failure. So let's find the probability of heart failure. Okay, so the probability of heart failure. Well, let's see, how many patients have heart failure? When we're looking at this, this table here, looks like everyone in this column has heart failure, right? So that would be 30 plus 20. So 30 plus 20 divided by total sample size, which is 300. There's 300 people in this sample. Okay, we could add up all the different column or all the different cells, or we could just read the question. And the question, it says that the results are based off of a study of 300 randomly selected patients. Okay, so this comes out to be 50 divided by 300, which equals 0.1667. Okay, so the probability of having heart failure in this hospital is 0.1667. So let's find the probability that a randomly selected patient has cancer. Cancer. Let's look back at our table. So everyone in this row has cancer, right? So that's 30 and 58. So 30 and 58. Let's go ahead and add those two together. 30 plus 58 divided by 300. So that comes out to be 88 divided by 300, which equals 0.2933. Okay, so that's the probability of having cancer in this hospital. It's 0.2933. All right, now let's find the probability a randomly selected patient has heart failure or cancer. All right, so let's write this down. So we have heart failure or cancer. Okay, so in the previous video, we came up with the formula for this. This equals the probability of having heart failure plus the probability of having cancer. Okay, and then since heart failure and cancer are not just joint, we need to consider subtracting the probability of heart failure and cancer. Okay, so we've already found that heart failure, probability of heart failure, if we go back to the table, so probability of heart failure, that'd be yes to heart failure, is 20 plus 30, that's 30 plus 20. So actually, let me go ahead and circle those using red. Okay, so that's 30 plus 20. It's yes to heart failure. So 30 plus 20 divided by 300. It's 300 in the sample. Okay, and then the probability of having cancer. Okay, let's do that in a different color. Let's do that in green. So yes to cancer would be 30 plus 58. Okay, so let's go ahead and add that. 30 plus 58 for 300. Okay, then we need to subtract off the probability of heart failure and cancer. So if we go up to our table, who has heart failure and cancer? Well, these 30 people right here. And you can see how they were added in twice, right? So that's why I need to subtract it off once. So I need to subtract off that 30 I need to subtract off this 30 over 300. All right, so if you do this, you get 108 over 300. Let me go ahead and scroll over. So 108 over 300, that comes to 0.36. So the probability of having heart failure or cancer is 0.36. Right. Let's do one more example. So in a political rally, there are 45 Republicans and 37 Democrats and 16 independents. First question is being a Republican and a Democrat, are they disjoint? Is Republican and Democrat disjoint events? Well, given this information, it appears that they are, right? No one is both a Republican and a Democrat, or at least they didn't report that in this given this information. So we do not have anyone who is both a Republican and a Democrat, so it appears that being a Democrat and a Republican are disjoint. So the answer is yes. Okay, so if a person is selected at random, find the probability that they are a Republican or a Democrat. So I'll use R for Republican or D for Democrat. Okay, so using my addition rule, this would be R plus D. Now I could subtract off probability of R and D, but that ends up being 0 anyway. So that's basically minus 0 because being a Republican and Democrat are disjoint. Okay, so what's the probability of being a Republican? Well, let's see, there were 45 Republicans. How many people are in this sample? You need to add up 45 plus 37 plus 16. You should get 98. Plus, probably being a Democrat, it's 37 Democrats for 98. Okay. If we add those two up, you should get 82 over 98, which is 0.837. So the probability of being a Republican or a Democrat is 0.837.